And we're good to go, Daniel.
All right. Good morning, everyone. Welcome to the Flower Enterprise launch. We have some very exciting announcements for you in store today. So let's get started right away. For those on the stream who are new to Flower and federated AI, maybe, I want to spend just a few minutes to give a very brief introduction. So you might wonder why federated AI? Why are so many organizations interested in adopting federated AI? Why is the number of research papers in this space exploding? Why are we working on federated and decentralized AI at all? This might sound surprising to many, but fundamentally, what we are interested in isn't actually federated AI or decentralized AI. What we are interested in is just better AI. Um, so how can we train better AI models? How can we bring the breakthroughs we've seen in some AI domains into other domains? How can we help researchers and engineers solve important societal issues with AI? Let's look at what you need to build just fundamentally better AI models. If I had to summarize the approach for building better AI models in one word, it would be scale. Scale the model, scale the compute, scale the data. If we look at the history of breakthrough moments in AI, pretty much all of them were powered by scaling one or more of these dimensions in some way. If we take, for example, AlexNet in 2012 as a baseline, model size scaled from 62 million parameters to 2 trillion parameters in the case of Llama 4 Behemoth. On the compute side, we went from training AlexNet on just 2 GPUs to now over 200,000 GPUs in the XAI Colossus cluster. And on the data side, we went from ImageNet to training on pretty much all public data available on the web. And now we're adding into the mix a lot of synthetic data. Now, the typical way this is done could be called centralized. You build a data center with as many GPUs as possible, and they would need to be, and you would need to fill that data center then with data to train on. So in a sense, we're moving the data to where the computation is. The computation is in the central data center, and we move all the data into that central data center. That's why we could call this approach centralized AI. Now, the situation is that data is naturally decentralized. Data originates on different user devices or in different organizations. But as we all know, not all data can be moved so freely. So data is often sensitive and it's protected for good reasons. So this approach of centralizing the training data only works in some cases, and it doesn't work in many other cases. This is why frontier LLM training happens mostly on public and or synthetic data, because public data is public, so it can be moved. You can just freely access it. Um, but it doesn't work for so many other industries. The issue is why, for example, why are we not seeing the big AI breakthroughs in areas where data is more scarce? Medical AI is one such example. Now, there is an emerging approach for training AI that is called federated AI, or sometimes it's called decentralized AI. If you remember, in centralized AI, we said we're moving the data to the computation. In federated AI, we just flipped that. We're moving the computation to the data. The data, which is decentralized and distributed across different silos, always stays where it is. It could be in the silos of different organizations or silos, even within the same organization, maybe across data silos across different continents, for example, or it could be even on different user devices. In federated AI, each silo retains full control over their data, and each silo contributes their own compute to the federation. So again, instead of moving the data, we're moving the AI models. We let the AI model learn from the local data in the different silos. And by doing this, the training can access vastly more data and often also more compute, which gives us what we wanted to have in the first place, better AI models. Now, this approach requires some infrastructure to make work. It's a fundamental shift. Instead of moving data around, we're moving AI models around, and we're doing so often. In a single training run, the AI model might be exchanged between two nodes multiple times. So one thing we notice is that for many, the question is, yes, we understand the benefit of federated AI, but how should we do it? Well, Flower's mission is to make federated AI the new default. With the Flower framework, we built a platform that handles the largest part of this complexity for you. It allows you to bring your AI model and then run it federated across more data and more compute. This is great. It doesn't require ML researchers and engineers to relearn what they know. They can just continue to do what they do best, but now with more compute and more data to produce better AI models. In fact, we're putting a lot of effort into making it easier and easier with every release that we do. It's now almost trivial to get started, even if you've never used federated AI before. Using Flower and federated AI is now as simple as just two commands. Flower new or FLWR new is used to create a new project based on a number of built-in templates. For example, you can easily create a PyTorch-based project or an XGBoost-based project. And then Flower Run is used to run this project in a federated way. And that's it. You can go ahead and you then have a fully working project that you can run. And you can then go ahead and you can start to customize the project. You can tweak the model. You can replace the model with your own model and follow the typical machine learning workflow that you would use to train any kind of model. While it's easy to get started, Flower is also deeply customizable and extremely powerful if you want to go deeper and if you want to customize different parts of this stack. It allows you to use pretty much all of the models you already use. LLMs, for example, we have a special announcement about LLMs later. I don't want to say too much, but I think it's safe to say that since Flower 1.20, the release that we just got released on Tuesday, Flower is now the best platform to build federated LLMs, and it's not even close. But of course, you can also use any other kind of model, any other type of model. You can use regular neural networks, convolutional neural networks, for example, very popular among our medical AI community. Or you can use boosted trees, very popular among our users in finance. But so getting the everyday user experience right is just one component, right, of the overall picture of getting a federated AI system into production. When you want to go to production, you need a lot more. You typically need Docker containers, you need first-party Kubernetes support, and you need it to be nicely integrated with the framework. You probably don't want to go ahead and build and maintain your own containers. It's a lot of ongoing work. It's error prone, and you can easily inherit security vulnerabilities if you don't spend a lot of time on it. So I'm happy to just report again that Flower has first-party enterprise-grade Docker and Kubernetes support built in. So we offer first-party Docker images. We offer hardened Docker images. Our Docker images are continuously scanned for vulnerabilities. And we've made a ton of vertical improvements in the framework to make the framework play nicely with Docker and with Kubernetes. In fact, our own deployments of Flower, they all run on Kubernetes. And we enable Flower users to do the same. So maybe enough about features, but let's switch gears a little bit. The thing that I really want to highlight, the one thing that makes Flower really special is the community. Flower has a huge community and it's growing quickly. In fact, every time we show this slide, we have to update the numbers because those numbers are changing so quickly. Um, Flower has over 6,000 AI researchers and AI engineers on the public Flower Slack channel, and we have more than 6,000 stars on GitHub. Here are some impressions from our community. The Flower AI Summit in March in London was the largest federated AI conference in the world. We had over 3,000 people on the live streams. The venue in London was fully booked out. I think some people were even sitting on the floor. I'm still sorry about that. And it was amazing. There's so much momentum in the community, so many projects that are just getting started that I can't wait to see the results next year. I think it's safe to say that the Flower community is booming. Um, Federated and decentralized AI come in many, many different flavors. This is something we learned from the many projects we do in very different industries. So we built the Flower open source project to be incredibly modular. Many users know how flexible Flower is on the application layer. So you can customize your apps, the strategy you use to select clients and aggregate results, the privacy enhancing technologies you use, the models, the ML frameworks, the way you load the data. Fewer people know that Flower is actually also quite modular on the infrastructure layer. The communication stack, the execution, it supports plugins in different places. You can even swap out the full runtime if you want to. And this is amazing. It allows users to build and customize their federated AI system and integrate it with all the other existing systems they have in place already. For example, to load data from some existing system that holds patients' records in medical AI, for example. But customizing all of these different parts of the framework to work really perfectly fit your needs can also be a lot of work. So Flower is used by an incredible group of organizations. We work with many of them directly. You can see some of them on this slide. Organizations from very different industries, consumer like Mozilla and Samsung, the largest industry organizations like Bosch and JP Morgan, for example. JP Morgan recently announced their usage of Flower, best-in-class academic institutions, but then also other organizations like the major cloud providers and the US Air Force. So when we work with these organizations, there were some requirements we heard over and over again. And we help these organizations individually to address these requirements. But again, we realized that we were doing some of the things over and over again. For example, user authentication. It's really important for enterprise users. Many of them use OpenID Connect to authenticate their users. But it's also not something that we wanted to build too deeply into the framework because we knew that some users had different authentication and authorization systems in place already, and they wanted to use other solutions. It would be wrong to force all users of Flower to use OpenID Connect. I think, in fact, if we did that, we would make Flower worse for a large part of the community. So we asked ourselves the question, can we preserve the flexibility of Flower, but then make it easier to deploy a production-ready Flower system, an opinionated one, in maybe just 10 seconds? Today, we are introducing Flower Enterprise. Flower Enterprise is a version of Flower that combines the flexible Flower open source project with a set of opinionated extensions to accelerate the deployment and development of production-ready, scalable, maintainable, federated AI systems. Maybe to put it simply, it's the fastest way to get federated AI in production. With Flower Enterprise, you get a full all-inclusive package to go live with federated AI. And you can do so really quickly. It builds on the amazing foundations of the Flower open source platform. Based on the learnings from many industry projects, we complement the open source project with a set of opinionated enterprise extensions. Um, we call these enterprise extensions opinionated because they come with a set of best practices and opinions built in. Things we learn from projects that we do the way we think is a good way to do them, but they're not the only way to do it. So this is why we call them opinionated. It might not be the right solution for everyone, but it will be a great and robust solution for many. And this is why we call those extensions opinionated. It's our experience just distilled into code. Um, but the beauty of open source, of course, still guarantees you that you can write your own code and you can continue to customize the open source framework. I mentioned Flow Enterprise is an all-inclusive package for enterprise users. Apart from enterprise extensions, Flow Enterprise also comes with full enterprise support. Via our enterprise support, you get guaranteed response times, you get access to the Flower team. We can help you with any question you may have, whether it's related to Flower itself, or the models you want to train with it, or the infrastructure you want to run it on. And if you happen to run into any issues, we're of course all ears, and we have a quick path to fixing issues on all the layers of the stack. So to put simply, the idea behind Flower Enterprise is quite simple. By combining the flexible open source platform with a set of enterprise extensions and enterprise support, you can deploy enterprise-grade federated AI quickly, securely, and reliably. This accelerates your time to market, your time to getting a system deployed a lot. It's an opinionated solution with a set of best practices built in. If you're an advanced user and you want to invest the time, you can, of course, still fall back on the modular open source project. You can customize every single detail. I think that's the beauty of open source. Now, something I want to highlight, something that I think isn't discussed enough, is the different layers of the stack in federated AI systems. Running and operating a federated AI system requires you to get all of these layers right, not just a single layer. It often starts with some R&D experimentation. Which model could we train on the data we have? This is then tied to an application. So what could our model help us with? For example, we could build a computer vision model that helps to diagnose radiology images in a medical AI setting. The application is built on top of a framework like Flower, but when you actually run this into production and you want to run this across, I don't know, maybe many hospitals, the framework needs to be integrated with other systems, for example, to load the data from some existing system. All of this taken together needs to run as one platform. The platform needs to be operated and maintained. You probably want to support professional support if something goes wrong, someone you can call who helps you to fix anything that comes up. And ideally, you also want to have some help if you need it with your specific solution. Someone who can even help to debug your application, to help you train better models, find better hyperparameters, to make sure your models are converging nicely. Ideally, all of these items are vertically integrated. You want them to work really, really well together across all of these different layers, especially if you deploy the system in production and you scale it up. One thing we noticed, though, is that this is sometimes not obvious to users. So, for example, we noticed that there are often comparisons between different frameworks. We love to see these comparisons because Flower usually does pretty well in these comparisons. But we also want to caution against, even though Flower does well, we actually want to caution against these comparisons because they only cover one of these 8 layers. The reason we bring this up is that you can pick a framework for a particular reason, but then often you're on your own when it comes to the remaining layers. You'll have to figure out how to wrap that framework in Docker and how to run it on Kubernetes. you might or you might not get the support you need. You need to build all the integrations yourself. Sometimes this work is done for you. So sometimes someone just takes an open source framework that has been built by someone else and integrates it with a bunch of other tools to give you, I don't know, metric logging and things like that. And then they run it for you. So someone like that would cover the integration layer and would cover the platform layer. But if something goes wrong with the framework, all they could do is open a GitHub issue and hope that the authors of the framework actually fix the thing that they ran into. Um, some providers, they run everything for you. But they have the same issues, right? If something goes wrong, they can only open GitHub issues with all the other layers and then hope something gets fixed and hope they can deploy a new version. Sometimes it can be hard to tell what type of entity you are thinking of working with. You can just simply ask them, did they build the framework they're using under the hood? When a change in the framework is needed, how do they control how and when that change in the framework is implemented? Now, an ideal solution, of course, would be vertically integrated. All the layers are working nicely together. And I want to highlight that this is exactly what we at Flower offer. We do the research, check out, for example, Flower LLM. We build sort of applications that are pushing the limits of what's possible. We help customers also to build applications. We optimize the framework for all the cases, use cases that our users want. We build the integrations. We integrate, for example, with popular tooling. We make it easy to run this as a platform. We can even operate it for you if this is something you want. You get first-party support from the people who who develop the framework. And if you need help, we can even help you with the application. What I find interesting is that you would typically think that these layers are somewhat nicely separated, but working in many projects, we realize that often you need to make changes across several layers to achieve the optimal outcome. We've made many of these optimizations already, for example, to make the framework much easier to operate on Kubernetes. We implemented changes on the framework layer, and then our Kubernetes integration just got a lot nicer. And all of these contribute to the overall user experience that users are expecting from us. So I'm over time a little bit, I'm speeding up now. This is Flower Enterprise. It's the popular open source platform bundled with a set of enterprise extensions and enterprise support. In our opinion, it's the best solution for production-grade federated AI. Enough from my side. Let's actually hear from one of our Flower Enterprise users. So today we have Matthieu from Owkin with us. Owkin is an AI biotech company that unlocks complex biology to find the right treatment for every patient. One of the things that Owkin is well known for is they were one of the earliest pioneers of federated learning in medical AI, way before most people even knew that federated learning even existed. And Matthieu works as a team lead at Owkin. His team works at the intersection of ops and research tooling and is often involved in special projects such as deploying FL systems. Matthieu, welcome.
Thank you. Hi, Daniel.
Hi. To kick things off, maybe let's start with a high-level question. What's the relevance of federated AI in your industry?
So that's something you mentioned when you explained the difference between centralized and decentralized approaches. Um, as you mentioned, there's some data that cannot move, and especially healthcare data, which is of special interest in at Owkin. So we end up in situations where to answer a particular biological question, we need to have access to multiple data silos, and we cannot, collocate them at the single in a single system. So we need to rely on FL to be able to train models and to actually do something with the data, which is scattered across multiple partners. So this is the specific relevance of FL at Owkin.
That makes sense. And as we've seen, accessing more data, then hopefully, well, we're pretty sure that this will lead to much better AI models. Um, so before partnering with us, what challenges were you facing?
So as you mentioned, we were using we were doing FL for a while at Owkin, using our in-house system, Substra. And a while back, we were in a situation where we had live running systems we needed to maintain. We had upcoming projects, but we didn't really have the engineering bandwidth to maintain all of that existing systems, in addition to bringing new features to the framework. So we had to make a decision, and basically we wanted to shift from a build mindset to a buy mindset. So that's where we started to, look out in the market, what was available, what would be the options for us, and start looking into what would be the best fit for Owkin.
So what made you decide to adopt Flower in the end then?
So obviously, we compared the different options, and I really like the way you present the vertical integration, because since we had firsthand production experience with FL, we were really wary about marketing promises. You can get started on some framework, but then once you want to move up to the production layer, that fails, or that's way more complex than expected. So we had kind of a lot of criteria to compare different solutions and frameworks, and basically we were interested in obviously the technical soundness of the solution, what we would be able to achieve with the framework, but also how easy it would be to communicate and get up with support. So from all the different options, I guess we were quite convinced in the technical approach, because we've seen what worked well in production for us, and the tricky areas that needed special care. And well, yeah, the communication was pretty easy to get started. So obviously we first played with the open source approach, and 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 then, well, got started into the partnership.
I remember these early conversations extremely well. I was impressed by how knowledgeable Owkin overall was about federated learning. You knew all the small details. You had super deep questions, and it was a really great experience. Um, could you walk us through how your team used Flower to solve the challenges you were facing?
Yes. So basically, we had a couple of requirements we knew we had from the existing systems. And then we had upcoming projects. And basically, most of the time when you start discussing with a partner, they have their own set of requirements. And it turns out that most of them share similar requirements, but with some specificities. So we started building kind of a big list of requirements and said, okay, uh, from the upcoming project, this is what would really be the core requirements. You mentioned user authentication on OpenID Connect. That was one of them. We needed some kind of permission system. We had internal requirements as well, such as the ability to deploy in Kubernetes, to make things more standard across the different deployments. And so basically, we came to you with that huge list of requirements and said, okay, how can you help us? Can you deliver on them? Is it planned? Is it on your roadmap? How can we move forward with that? Um, and then, I mean, basically you delivered on the most critical requirements. So we were able to start deploying Flower, and actually make sure that everything was compliant with our requirements, our partners' requirements, and so that we would be eventually able to deploy everywhere we needed to.
And how has our support team contributed to that experience?
So I would say the availability. We tend to work, in a mix of asynchronous and synchronous operations. And I think that worked well with your team as well. We were able to iterate quite fast on some questions, like when we were deploying for the first time with the Helm charts and Kubernetes. We had some nitpicks, questions, and it's super frustrating when you start working on some topic and you had context switch because you're sending an email and so on. And well, basically your team was super available. We were able to spawn calls when needed through Slack, be able to answer quite fast on some detailed questions. So that was really good. The collaboration and communication was pretty good in that aspect. We had a clear roadmap, we had a clear requirement list, and you were very clear on, okay, this is planned for the next release, this will be coming in the next one, or maybe the other one. And everything was super smooth in that aspect. We knew where we were going, and we
That's
appreciated that.
that's great to hear. Thank you. So is there anything you would say to other enterprise users who consider Flower?
Um, well, yes. As you mentioned, we had experience with FL. So in a way, we knew what it meant to run something in production, and we knew the constraints to operate FL network in production with industrial partners. And well, I would say that you know what you're talking about. You have some experience as well, and that's super reassuring. So I guess that's what we can share to potential enterprises as well, that they can rely and benefit from that experience of yours.
Awesome. And then maybe as a last question, zooming out a little bit, in what ways has our platform helped you to stay ahead in your industry or market?
As I mentioned, we had it would have been super hard for us to bring new features to Substra in a short amount of time due to limited bandwidth on our side. So we still wanted to maintain that capability and say, okay, if at some point we have a partnership with a very specific medical question we need to answer, and we need to rely on federated learning for that, we just want to be able to launch computations. So basically, we wanted to be able to focus on the actual science and much less on the technical aspect of things. And I think that's really what we achieved with our onboarding on Flower, that we are confident we can deploy Flower and run an actual project. And I mean, my team basically can help our colleagues focus on what they do best, which is actual science.
Mm. I can confirm that building a framework is a lot of work. So I understand that part. Thank you so much for joining us today, Matthieu. It's truly an honor to be working with you and with Owkin, one of the true pioneers in federated AI. Yeah, thanks for joining.
Thank you, Daniel.
So we originally planned to have just one guest today, but actually, as a small surprise, we have actually another amazing guest today. So today we also have Nikolas from i2gene with us. Nikolas is a co-founder of i2gene Limited, a software company that is applying AI to genetic eye diseases to help patients get to treatment earlier. He has over 10 years of experience working in eye care and genetic research. Nikolas, welcome.
Hi, Daniel. Good morning. Thank you for inviting me.
Good morning. To kick things off, what is i2gene?
Yeah, so we work on the problem of genetic eye diseases, which is a leading cause of blindness in people under the age of 30. And it's really difficult for these patients to get diagnosed because these are diseases which are individually quite rare. And so what we've developed is an AI solution that basically is helping patients to get diagnosed and treated much faster. And the AI works by taking as input retinal scans and is able to predict to really high accuracy the precise diagnosis at the genetic level for an affected person. So to say which specific gene is affected in a person.
This is such an important area to work on. I remember reading a study where some of these diseases they can even lead all the way up to blindness. And the thing I found fascinating was that if you detect them early, you can treat them very well and you can prevent people from going blind. So a very, very important work, I think, in that area. Um, so what kind of challenges were you facing before partnering with us?
Yeah, so we want to develop an AI solution like everyone that works in the medical space that works across different ethnicities, people from different genetic backgrounds, and so on. And this is in particular, it's very important for ITGene because we are specifically looking at the genetic causes of these diseases. So we really need a global data set across multiple sites all over the world so we can generalize our model better and we don't increase the disparities in healthcare. So we really needed representative data sets. However, as Matthieu from Owkin said, and this is a problem across healthcare that data access is a big data access is a barrier, and data centralization is difficult. And this is obviously due to concerns around privacy governance, but also sometimes some lack of infrastructure or some lack of support in the different sites. For example, they are too busy, and rightfully so, working on healthcare and research is not something that they have dedicated staff to support.
So you touched upon this a little bit already, but what's the relevance of federated AI in your industry? What made you decide to adopt Flower in the end?
Yeah, so federated learning does address some of these issues that I just mentioned. So around data sharing in particular. So for example, we can set up different at the different sites. We can set up their infrastructure so they can share, so the data can stay local, and our models can come to the data to train. And it reassures them that they remain owners of their data. They're not sharing it with another third party. And also, we can put in the right access levels there to ensure data minimization. And we were very interested in applying this technology of federated learning. And to us, Flower seemed to be one of the most advanced and stable frameworks, and also with a very huge community behind it, which you've highlighted. So for us, this was an obvious choice. And also, we knew a lot of the people behind Flower, in particular the academic team from computer science. So we knew they would have very good, scientific foundations, algorithms behind it as well.
So your team used Flower to solve these challenges you were facing. Could you walk us through how they did that?
Yeah, so we did this as part of a pilot, which was supported by the UCL Center for Digital Innovation, and that was powered by AWS. So we had AWS support for this. So, but we worked with the Flower team to set up two virtual private clouds at two sites as part of our pilot. And then our technical lead, who is led by a technical team, sorry, that is led by our CTO Ismail Mogul, suggested that we use a sort of Nextflow pipeline coupled with AWS AWS batch, sorry, in order to communicate with the Flower clients. And that allowed us to run Flower compute on small servers that were always running, but also offload the more intensive compute to GPU machines using cheaper spot on instances that was managed through AWS batch.
I remember that from your talk at Flower AI Summit. That was a very interesting approach. I kind of like that, just spinning up the GPU instance whenever you need it, but not keep it running all the time. Can you already share any measurable impact on the quality of your federated models after adopting a Flower and a federated approach?
Yeah, so obviously this led to an improvement in the accuracy of our model, being able to use these data sets And what was nice as well is that it was quite quantifiable what was the contribution from different sites. And also, as Matthew said, it was really nice that we had this amazing support from the flower team, because we were able to concentrate on the science and get help from the flower team on setting up the federated approach. So yeah, and it's also given us some new ideas as well about how we can take this further in the future.
So after getting started with federated AI, was there any influence on you? You started with the company pretty recently, I would say. Was there any influence on sort of the business or project strategy for I2Gene?
Yes, so I mean, one of our major selling points of I2Gene is that we've been trying to work with global data sets, and we have amazing partnerships already with lots of hospitals. But what Flower is giving us is the means, the infrastructure to set up strengthen these partnerships and set them up in a much more, I think, meaningful and collaborative way, so that we can, for example, quantify the contributions from the different sites much better, and also give sites reassurance that they still keep control their data. It's also given us incentives in terms of our technical roadmap to focus a bit more on VPCs and setting up VPCs at the different sites, and in particular, Flower enabled obviously VPCs so that we can work with Flower. And also, I think in terms of, because we are obviously working in the medical space, and safety is a big concern and issue. So it's helping us with our clinical deployment plan as well to monitor sort of data drifts that we could do potentially in real time or near real time with Flower. And this, for example, happens quite a lot in our space, because the devices that acquire the images can get updated, and then that can cause downstream implications on the data. So it's important to monitor this. And also, in the future, as our I2Gene gets regulated, and we enter the post-market surveillance phase, that's also going to be very important. So I think all this has helped us enhance our strategy and also our business valuation.
Pretty interesting. And has our support team contributed to your experience in any way? Any feedback from the team?
Yeah, so I really want to echo what Matthieu said, that I think what set, because we've worked with other people in the past, and what really set Flower apart ahead of the competition, I think, is that the responsiveness of the team has been really good, really exemplary on Slack. We've had very good interactions with the team, a lot of flexibility as well around setting up calls when needed, and bringing in the right people at the right time to solve problems. So I think we've had very good interactions, and also very receptive also to feedback and suggestions from us on how new features could be incorporated. For example, I mentioned the AWS patch and Nextflow support, for example, how that could potentially be on the roadmap and be useful for other people as well. So yeah, very, very positive overall, yes.
Nice. I think we have some good features there coming up. Maybe to close out, is there anything you would say to other enterprise users who considering Flower?
Yeah, so I think firstly, if you're not using federated learning, you should definitely consider using it, especially if you're in the medical space, because it is, I think, the future of how medical AI is going to be working. And if you're going to go for federated learning, I would strongly suggest you reach out to Flower, because they've just got so much experience in this space, working with great partners, as we've seen, for example, Owkin and many others. So lots of relevant experience, I'm sure they can share and help you help you develop the business and reach out as many patients as possible around the world.
Thank you so much for joining us today, Nikolas. I can only echo what I said in the beginning. I'm a huge fan of your work. I think it's such an important area to work on. And I think it has the potential to create sort of an AlphaGo moment for federated AI at some point once we start to scale up these systems. So thanks again for joining us today.
Thank you so much, Daniel, and lovely to meet you all. Take care.
With that, I'm handing over to Javier to go deeper on the new Flower Enterprise extensions and to show you a live demo. And who knows, maybe he even has a small or large LLM surprise in store for us. So Javier, over to you.
Okay, great. Well, thank you, Daniel, for the exciting mini introduction to my session now. So I'm very excited to bring more details about the Flower Enterprise extensions today in this Central European Time Zone session for the launch of Flower Enterprise. Before we jump into the details, just want to give some high-level overview of what we have built and why we built it. So the idea behind federated learning is that by definition, almost they are all the time distributed systems. So this means that there are different components that run at the very least in different networks, but more often than not in different organizations and in many occasions in many different clouds. There are also, in addition to these systems, there are also users that want to interface with these systems. For example, clinicians or biotech engineers that want to run their workloads, like for example, to train the next best of the best image medical detection model, for example. So the enterprise extensions we have built allow you to seamlessly deploy, operate, and scale your use cases as your business needs grow, and also to maintain all these systems during the life cycle of your use cases. And because they have been built by us, the team behind Flower, we can give you several guarantees that are quite relevant, especially in enterprise. One, that they have been natively integrated within the framework. We developed the framework, so I think we have a good idea on what's the best way to integrate all these features we're going to be discussing about very soon. Two, they have been thoroughly tested on a number of use cases and in different scenarios. And three, they will evolve over time as Flower gains more and more features with each new release. So today we want to give you a bit more details on 4 exciting enterprise extensions. Some of them have already been highlighted by Daniel, and some they haven't. So I will tell you more about them very soon. The first one is related to making seamless deployments of these complex distributed systems. Flower has best-in-class Kubernetes support, and you can deploy the entire federation via Helm charts. That's our first enterprise extension we're going to talk about. The second one has to do with user authentication and authorization. We have implemented an extension that allows fine role-based access control to your users. So only those that should interface with the system can do so, and only those that have special privileges to run certain workloads or run certain operations can do so, whenever the admins of these federations want to allow for this kind of uses. Next, there will be audit logging, which, as we'll see soon, enables you to have a complete overview of the user and system interactions in the system. For example, to know which data scientist is running which workload, but also to capture events that happen between the different components in the system. And we'll see this in more detail very soon. And I will highlight another enterprise extension later on. And there will be more that we'll be sharing with you in the next weeks and months. So let's jump into how you can deploy a federated learning setup using Flower with Kubernetes via Helm charts. So the key idea here is that in enterprise, we don't want surprises. We want the process of deploying the entire federated learning setup to be reproducible, easy to action, and that it can be version control. This is the kind of reliability that DevOps team expect. And we can assure you that we deliver on this front with the Helm charts support on Flower. But before I present to you how easy it is to get this deployment up and running, let me give you a brief overview about the main components in a Flower federation. So there are 2 distinct types of components: the supernodes, which are services that run where the data is. For example, in a hospital, maybe there are some GPUs attached to the data, or in a bank. So these supernodes are services that connect to a superlink, which is like a central server that helps orchestrate the entire federated learning process. The superlink is also the entry point for users, authorized users, to interface with the federation to run workloads. And collectively, the network of superlink and supernodes, we refer to that term as a Flower Federation. So to spawn the entire system, we can do so by means of two Helm commands. One to spawn the superlink, and then to spawn the relevant supernodes. And we have pre-recorded a short video to show you how easy it is to do so. So let's take a look at the video. So this is a terminal where we are gonna first install the Helm chart for the superlink. It is as easy as running this command. And immediately after, we can see that a pod has already been deployed for the superlink. Here, I'm copying the name of the pod because, for example, I want to attach to the logs of the superlink to see what is its status. So we can attach to the logs like that. Now with the superlink up and running, we can also deploy our supernodes. There is already a Kubernetes cluster running, so running the Helm chart allows me to deploy, in this case, 3 supernodes, just like what we have in the diagram in the previous slide. And we can see that the 3 pods are running and the logs are showing that the connection has been established. Moving to the next slide. Yeah, so that was how easy it is to deploy a federated learning system with Flower using Helm charts through a Kubernetes cluster. Next, let's talk about letting users interface with this system. So once we have a federation already running, we want our users, and only those that we authorize to do so, to interface with it. So for that, we have an enterprise extension that binds authentication and authorization, which allows you to customize who gets access to the system and with what type of role this person gets access to the system. And this can be configured quite easily by means of a single YAML config, which is quite modular, as you can see here. There is a section for authentication to set it up based on OpenID Connect in this case. And there is another section for authorization that allows you to set up fine-based access control to each of your users to the system. So with a superlink setup with authentication authorization, now the question is, how do a user starts interfacing with this system? So for example, let's say we have here Anne, and she wants to run a workload to train the next biomedical model using all the data that is distributed across these 3 supernodes. So the first step that she has to go through is to authenticate with the system. And there is a short command to do so, which is called Flower login, which if she has access, if her profile has been present in the authentication authorization database that is available to the superlink, she will be granted access. And after logging in, she will be able to run different type of workloads depending on her role. For example, she might be able to see the runs that have been submitted by other members of the team, and she might also be able to run her own research through the federation. An interesting bit is that if there is a second user, maybe from the same team as Anne or from a different team, if this person is also authorized to interface with the system, he would follow the exact same process. Flower login, and then he would be able to interface with the federation. And we're going to see a quick demo on how this actually works. So to do that, I'm going to share my entire screen. Well, I'm going to share my terminal. No, my entire screen. So here I have a terminal. It's a standard terminal. I have already a Flower app, which was created with Flower new, a command that Daniel presented earlier. And what I want to do is I want to, for example, let's try to see the runs that have been submitted to the federation. Well, I could do that with Flower ls, pointing to my remote federation, but in this case, I see a message saying that I need to first log into the federation, and that makes sense. I haven't logged in. I'm not authorized to interface with the system, even if I know the URL of the superlink. So to log in, I'm going to do exactly what the helpful error message tells me. So I'm going to do Flower login, and I'm gonna log in for this particular application in the remote federation that I want to access to. And for that, this has kick-started an authentication process in Superlink, and it prompts me to authenticate via this URL. So for that, what I'm going to do is I'm going to open a new tab, go to the URL, and I need to paste my credentials. In this case, I'm going to authenticate as Anne. I'm going to copy the password I have over here. And once I authenticate, I will get a successful login message. And now that I'm authenticated, I can proceed with what I wanted to do originally, which was, for example, inspect the runs that my team has executed in this federation. And now, indeed, I can see via the command line a very simplified way to see the type of runs that have been submitted, their status, and other interesting metadata. I could also, for example, submit my own experiment, and we can do that via flower run command. For example, flower run, pointing to the remote federation. And also because remember, all this is going to be executed remotely, I could optionally set a flag that allows me to securely stream the logs of my application. So for example, if I submit this, I would see that my run immediately starts, and I can see that we are going into round 1. There are 14 supernodes connected in this setup, so I'm involving all of them in each round. And if, for example, I Control-C that, and I do flower ls, I could see that, yes, my run is indeed still running because it's going to run for a number of rounds. So that's the typical and fairly straightforward flow for an authorized user to interface with the federated learning system. So let's go back to the slides. So that was a quick demo on how to log in to a Superlink running with enterprise extensions with an authentication and authorization layer on top of it. Now, let's talk about audit logging. It is quite important in enterprise to have a full and complete view of what's going on through the system. In the end, this is a distributed setup where there are multiple entities like Superlink, a potentially very large number of supernodes, each of them holding potentially sensible data. There are users interfacing with it. So we want to be able to, as the admin of a Superlink or the admin of a federation, we want to be able to trace how our system is behaving and to trace what are the interactions between users and the system. For example, what I did with Flower Login, what a user did when she, for example, submits a run. We want to be able to trace those. And also we want to be able to trace events between different components. For example, if the supernode has finished training a model and is pushing it back to the Superlink, we want to be able to see, for example, the timestamp when that happened, and that kind of information. So all these audit logs follow a very standard JSON format that can be consumed by other technologies, like, for example, Elasticsearch. And you can find more information about that in the documentation. So that was audit logging. One final enterprise extension I want to bring more details about today has to do with user interfaces. So we understand that not every user has to go down to the terminal to interface with the federation. Sometimes there are decision makers that only want to see the results of an experiment, or maybe there are admin of the federation that they want to better manage the Superlink and maybe the supernodes via graphical interface. So we are building graphical interfaces for this, and the one I want to show you today is the one we have for the Superlink. So for this, I'm going to share my entire screen again, and I'm going to drag here the Superlink UI we have. We did a very early preview demo in the Flower Summit, but now we have been improving it quite substantially since then. So here, what we can see, here I'm in my login screen, I can see a bunch of supernodes that are connected. Remember, in the experiment I just ran, we had 14 supernodes. This is the federation I was interfacing with. Each supernode has some metadata associated with them, so we can display them in the map quite nicely. We can see the node ID of them, and so on. More interestingly, however, is the runs tab, where I can see all the runs that have been submitted through this federation, including the run I submitted just now, and others that have been submitted by people in my team previously. So for example, we can take a look at this run for a fraud detection example we have built, and we can see exactly the same type of logs we would see in the terminal, but because of this graphical user interface, we are capable of doing a much more seamless interpretation of these results. For example, I can see that the area under the curve is going up after every round, and the loss is going down. So this is a quick preview of what the UI for the Superlink is going to look like. There will be other UIs for other components in Flower as well. Now back to the slides. That was a quick demo about the web UI for the Superlink. And this was a high-level overview of all the enterprise extensions that are ready in Flower today. We don't want to stop there, and we also are excited to share with you two big updates that have come to the Flower framework, the open source version of the Flower framework, that make even better also the enterprise experience. And there are two of them. One of them is large weight support. So Flower, all the messages that are used between the different components in Flower, like superlinks and supernodes, are built on top of protobuf, which is the industry standard for having a very well structured yet versatile definition for messages. But they come with one critical limitation that was not a limitation not so long ago, which is that their maximum size is 2 GB. So that naturally prevents you from communicating very big payloads, like very big models, for example, like the biggest LLMs. So today we are very excited to announce that in the latest release of Flower, as of Tuesday, this limit is gone. You can now federate models as small as a tiny XGBoost model and as big as you really wish. 1 trillion parameter LLM that is now possible to federate with Flower. Another announcement is that now all the communications in Flower is by default benefiting from broadcasting and streaming. Essentially, this means that your system spends way less time idle waiting for the communications to be completed. We call this technology content addressable message. It's built on top of the fundamentals of other popular technologies like Git, and we'll have a much more technical report to share more information about it very soon. But the key idea here is that it allows you to save NX communication cost from your server app to the Superlink. This is thanks to broadcasting. So if you have, let's say, 100 supernodes, 100 hospitals in your federation, and you want to communicate to them the same global model at the beginning of a round, thanks to broadcasting, you save 100x in communication, which can be huge in enterprise, especially if the communication links you pay for in your infrastructure are expensive, and often they are. And thanks to streaming, we are able to see an up to 3x wall clock reduction in total communication in a given round. And this is possible because also the large weight support capabilities. Now all the messages can be chunked into smaller messages, and this effectively allows a pipeline communication protocol in your federations. And the best thing is that these two components happen transparently to Flower users. So if you update to the latest version of Flower, everything you get it for free, and even better, you don't need to change anything in your code. So to give some perspective of what this means, we ran a demo in the last weeks of pre-training a 8 billion LLM, which is comes distilled from DeepSeek R1. It's in Flow 16, so it makes the model size, the entire payload size, 16 GB per model. And we have 5 supernodes distributed in different countries in Europe. We were able to observe a 5x upload bandwidth savings because of broadcasting. And because of the streaming capabilities in the communications, we observe a real-world 2.x wall clock reduction in communication. This means that during the entire life cycle of your run, of your experiment, you spend a way larger fraction of the time actually training the model and less of that time communicating it, which is really good news when you want to scale up the size and the capabilities of your federated learning workloads with Flower. So this was a preview of these two new exciting features that are coming to the open source framework. Large weight support allows you to federate any workload of any size, and content addressable message makes you have super efficient communication protocols between the different components in Flower. This was the overview we wanted to give you today about Flower Enterprise and these two exciting features that come to Flower open source as well. We'll have more to share about these last two features in a technical blog post very soon. So I can't wait to see what you build with them. Now, back to you, Dan.
Thank you so much, Javier. This is really amazing. Content addressable message and large weight support was a huge engineering project, and I think it just makes the open source project a lot better. The results you've shared are really a great example for what you can achieve with this. Anyone who ever looked into the pricing of traffic on popular cloud platforms knows that traffic can be quite expensive. So these bandwidth reductions, these reductions in traffic that you need to run these systems at scale, they will really have a considerable impact on your bottom line. They will save you a lot of dollars that would otherwise go to pay for traffic. So give it a shot, build on top of it, and tell us how you like it. I think it's fairly safe to say that Flower now has an incredible messaging system, incredibly reliable, efficient, and scalable to the largest models. So before we wrap, I want to share just one more message from one of our amazing partners. It's from Ryan, who runs Thunderbird. Let's roll the video.
Daniel, the audio is actually not working.
All right.
Daniel? Daniel?
Yeah.
The audio didn't pipe through on my end. I don't know if this is going to be a quick fix on your side, but I think it's okay.
I'm not sure how to fix that, to be honest. Maybe we just put in the final edit and then people can catch it later on YouTube.
Sounds good.
Yeah, Ryan was talking about our partnership. I'm sorry you couldn't hear the audio, but I want to add that the Thunderbird team has really been amazing to work with. Thunderbird has an extremely high standard for protecting user data and user privacy. We love working with Thunderbird to push the limits of what's possible and to show the world that great AI features can be built in a way that doesn't require you to collect user data, and that puts the user back in full control. So that's a wrap. Flower Enterprise is now here. It allows you to deploy production-grade federated AI systems in 10 seconds. It comes with user authentication and authorization built in. It has full audit logs. And of course, it has first-class enterprise support. Moreover, it builds on the thriving Flower open source project. It now comes with large weight support built around our unique content addressable messaging system, a highly reliable and highly scalable and efficient messaging system. A change that really saves you real cloud cost when running federated AI at scale. This is the advantage of Flower. We build everything we do, and we can vertically integrate it for the best user experience possible. If you want to learn more, please book a demo by scanning the QR code in the bottom right corner of this slide. Well, actually, before we completely wrap and take questions, there's one more thing I should mention. And that is in September, the largest federated AI conference is coming to San Francisco. On September 25th, we'll run Flower AI Day to bring together some of the best people in AI. We'll have some amazing speakers like Sarah Hooker from Cohere, Logan Fitzpatrick from DeepMind, Si Sang, the CTO of Together AI, Joe Spizak from Meta, and Timothy Chu from Stanford. And of course, we'll also update you on the progress that Flower has been making until then. You can scan the QR code to join, or just simply go to flower.ai and go to the website, see what the conference has to offer. Now it's a wrap. Thanks for joining us today, and we're happy to take some questions.
I'm monitoring the channels right now. I think there are no open questions so far.
All right, then I guess it's a wrap. Thanks, everyone.